Morning, Veda.
Good morning.
Am I audible, Veda?
Yes, sir, you're audible, sir. Sir, actually, I don't know, first time at this thing came, sir.
Streamer?
Recording. Yes, sir. Hello, sir. Can you hear me, sir?
Sure. So, what is the first question we have got? A bar magnet having a magnetic moment 10 to the power of your 4 ampere meter square is free to rotate in an horizontal plane. Okay. In
Yes.
horizontal magnetic field, 2 into 10 to the power of minus 5 Tesla exists in the space. Find the work done in rotating the magnet slowly from a direction parallel to the field to the direction 60 degrees from the field. What is the torque needed to maintain the needle in this position? Okay. So, what do we
Yes.
got to the question? We got a bar magnet having a magnetic moment, how much better? 10 to the power of 4 ampere per meter square. So I'll write the data there. So data given for me is question number 5. Magnetic moment. Magnetic moment is equal to how much? 10 to the power of 4 ampere meter
Meter
square. That
square.
is the given data.
Yes.
And it is free to rotate in an horizontal plane. A horizontal magnetic field is given for. So
Yes, sir.
horizontal magnetic field means how much is given for me? P. So
Yes.
horizontal magnetic field is given for me 2 into 10 to the power of minus 5
Minus
Tesla
5
exist
Tesla.
in the space. We need to calculate the work done in rotating the magnet slowly from the direction parallel to the field. That means if this is a bar magnet,
Yes, sir.
okay, and this is the south pole and this is the north pole, this is the direction of magnetic field.
Magnetic moment. Yes.
South pole magnetic moment is also from your south to north,
Yes, sir.
isn't it? Both of them are parallel, kada?
Yes, sir.
Isn't it? Both of them are parallel part of relation, isn't it?
Yes.
Now see here what is telling. Find the work done in rotating the magnet slowly from a direction parallel to the field to a direction of 60 degrees to the field. That means after certain times this magnetic field will be the same. There is no change in the direction of magnetic field, but the bar magnet is being rotated by how much angle beta? From 0 degrees to it has been rotated
60
to an angle of
degrees.
60
60
degrees.
degrees. Yes, sir.
So from theta is equals to 0, theta 1 equals 0 to theta 2 is equals to 60
60
degrees. We
degrees.
need to calculate the work done. Okay.
Yes, sir.
So
Yes, sir.
this is the position 1 and this is your position 2. Is it clear?
Yes, sir.
Now, if I'm calculating the work done to move from your point 1 to the point 2. What is the formula beta? U2
U1.
minus of
Yes,
U1.
sir.
Isn't it? So that will be equal to your, what is the formula in terms of magnetic moment? MB into your cos theta 1
Cos
minus
theta.
of your cos theta
Yes.
2.
Yes, sir.
No, so that is equals to your M into your B into cos theta 1. Theta 1 is how much for me? Cos 0 minus cos of your 60. Cos 0 is how much?
Cos 0 is 1. Yes, sir.
1 minus cos 60 is
1 by 2.
1 by
Yes,
2.
sir.
Isn't it? So this will become for me how much? 1 minus 1 by 2 is how much?
1
by
by
2.
2.
So it is mp by 2. So that will be equal to your half into magnetic moment is given how much for me? 10 to the power of 4 into magnetic field is given as of your 2 into 10 to the power of minus 5.
Yes, sir.
Isn't it? So this 2 and this 2 will get cancelled. This is 10 to the power of 4 and this is 10 to the power of minus 5. That means how much it will be better?
10 to the power of minus 1, sir.
10 to the power of minus 1. 10 to the power of minus 1 means 0.1
1.
joule.
Yes, sir.
Isn't it?
Yes,
Now we
sir.
got the work done. We can calculate even the torque acting on this one better. Torque formula, can you tell me? Tau is equals to your mb into your sine theta.
Sine theta. Yes, sir.
So that is equals to 10 to the power of 4. Magnetic field is given as 2 into
2
10 to
into
the power of 5.
minus 5. Minus 5, right, sir?
Yeah, 10 to the power of your minus 5.
Minus 5.
And theta is nothing but what? What angle it has been
60
rotated?
degrees.
0 to 60 degrees. Kabatti. This will be your sine 60 degrees.
Yes, sir.
Okay, now. So this will be
Yes,
equal
sir.
to how much? 10 to the power of 4 will get cancelled. This will be equal to 2
10.
by 10. Can I write like this?
Yes, sir.
Into sine 60 is
Root 3 by 2.
this
2
2, this 2
cancel.
will get cancelled. So it is root 3 by 2. Root 3
3
by 2.
10. Root 3
Okay.
by 10, right, sir?
Yeah, root 3 by 10. Sorry. Root 3 by 10.
Yes, sir.
Root 3 value is 1.732 divided by 10.
Yes, sir. It will go up means
So it will become for me how much? 10 to the power of minus 1. That means
0.173.
0.173 Newton meter.
Okay.
Newton meter.
Yes,
Newton
sir.
meter. So this will be the torque. Is it clear, beta? Is it clear?
Yes, sir. Yes, sir.
Isn't it? So I hope this problem is clear. Such type of equations, whenever you're calculating the work done, or the what do you call that one? Torque part of relation. Clear?
Yes, sir. Yes, sir.
Ingo problem చేద్దాం అలాంటిది.
Yes, sir.
Chalo, next question you try to first read the question carefully and see that whether what is the thing you are able to understand from the given question. Okay.
Yes, sir.
A short bar magnet is being placed with the axis 30 degrees within external field of 4 into 10 to the power of minus 2 Tesla. Experiences a torque of 0.08 Newton meter. Find the magnetic moment of the magnet. That is the first question. Find the work done in moving it from the most stable to the most unstable position. Second question is the bar magnet is replaced by a solenoid of a cross-sectional area 2 centimeter per second square and 1000 turns, but of the same magnetic moment. Find the current flowing through the solenoid. Sure. First question you can tell me. A short bar magnet is being placed with its axis at 30 degrees with an external field of your 4 into 10 to the power of minus 2 Tesla. Experiences a torque of 0.08 Newton per meter. Find the magnetic moment of this one. A short magnet
Yes,
is
sir.
being placed with the axis. That means
Yeah.
what do you mean by that one, beta? Short bar magnet is being placed with its axis 30 degrees external 30 degrees with an external field. That means magnetic field is given for me.
Yes, sir.
Magnetic field is given for me. B is equals to 4 into 10 to the power of minus 2 Tesla. And this is, say, for example, magnetic field. This is nothing but of your magnetic field. This is nothing but of your magnetic field. That is B bar. And in this one, a bar magnet is being kept, which is making an angle of your how much with the axis? 60 degrees. This is
Yes,
south
sir.
pole and this is north pole. This is the magnetic moment. This is nothing but capital A. Okay, na? So
Yes,
we
sir.
need to calculate the magnetic moment is how much. Torque is given for me in the problem 0.008. And theta is equals to 60 degrees. See, torque is 0.008 Newton meter. Okay.
Sir, how are we taking theta as 60 degrees, sir?
He is telling, na? He is telling in this one. You see right now here, experiences and so 30 degrees,
30
brother, not
degrees.
60
Yes,
degrees.
sir.
Yeah, sorry. So it is 30 degrees, not 60 degrees.
Okay, sir. Yes.
So this is your 30 degrees. This is your 30 degrees. So what is the torque formula, beta? Tau is equals to
MB into sine theta.
MB into sine theta. So what we
Yes,
need?
sir.
Capital M, gada. So capital M will be equal to tau divided by B into your sine theta. So torque value is 0.008 divided by B. B value is 4 into 10 to the power of minus 2 into sine 30. Sine 30 is how much, beta?
1 by root 2. 1 by 2,
Sine
sir.
1 by 2. 1 by 2.
Yes, sir.
So this one is 2. 2 so it will get 10 to the power of minus 2 will go up. That will become for me 10 to the power of plus 2. That means this can be written as what, beta? 8 into 10 to the power of how much? 1, 2, 3. 10 to the power of minus 3.
-3.
Antena?
Yes, yes.
Into
Sir.
this is 10 to the power of 2 divided by 2. 2 ones are this one is 2 fours are 8.
4, yes, sir.
This will be 4 into 10 to the power of this will be 10 to the power of minus 1, 10 to the power of 2.
-1.
This will be 10 to the power of
-1, sir.
minus
1, sir.
minus 1. That means 4 by 10. 4 by 10 means 0.4. Antena? Okay.
Yes, sir. Yes, sir. Clear,
Is it
sir.
clear? What is the next question is asking in this one only, beta? Magnetic moment is been over. Find the work done in moving it from its most stable position to your most unstable position part of relation. Stable position means what, beta? Most stable position is when potential energy is minimum. That thing you should always remember, beta. It's very, very important. Generally, students overlook such type of conditions. Whenever
Okay.
I'm using the word most stable position means u is minima. U is minima means that is theta value should be equal to 0 degrees.
0. Yes, sir.
Okay. Most
Yes.
unstable position ante most unstable position means u is maxima. That is at what angle? Theta is equals to 180 degrees. That means from theta 1 is equals to 0 degrees to we are rotating it to theta 2 is equals to 180 degrees. Isn't it? Most
Yes,
stable
sir.
position to your unstable position
Most
means theta
unstable
1 should
position.
be equal to 0, theta 2 must be equal to 180 degrees. So work done to move from 1 to 2 will be equal to your u2 minus of your u1, isn't it? So that is
Yes,
equals
sir.
to your m into b will be common into this one will be your cos theta 1 minus of your cos theta 2. I hope you remember the formula. What is the energy formula beta? Potential energy formula వచ్చేసి మనకు u is equals to minus of your mb into cos theta,
Cos theta. Yes, sir.
isn't it? ఈ మైనస్
Yes.
వెళ్ళిపోతుంది కాబట్టి that is the reason you are getting here theta 1 minus theta 2. Is it clear? So work done to
Yes,
move
sir.
from your 1 to 2 will be equal to, this is your mb into your theta 1 is nothing but how much? Cos 0 degrees minus of your cos of your 180 degrees. So that is equals to your m into b. Cos 0 is how much beta? 1 minus
Minus
cos
1.
180 is
So
minus
2.
1. Minus minus it will become for me plus. So it is 2 times of your m into b.
Yes, sir.
Okay, na? So that will be equal to 2. Magnetic moment already we got 0.4 into magnetic field is given how much for me? Magnetic field
10
is
to the
4
power of
into 10
minus.
to the power of minus 2. So this will be equal to your 4 into 10 to the power of minus 2. So that will be equal to how much beta? For 4 is 16, 16 to the 32. So this will be 32 into 10 to the power of, this will become for me how much? 10 to the
Minus
power
3,
of
sir. 10 to the power.
minus 3 joule. So this will be the work done.
Yes,
Is
sir.
it clear?
Yes, sir. Yes.
Okay. Chalo, very good question, beta. Question number 3. The bar magnet is replaced by the solenoid of cross-sectional area 2 centimeters square, and area is given for me, beta. So area is given, kabatti. So you know that when a solenoid is being converted into your bar magnet is been converted into your solenoid, the magnetic moment is calculated with the formula m is equals to your I into your A,
Yes,
current
sir.
into area of cross section. It is having number of turns, you multiply it with your n. N is nothing but of your number of turns. Magnetic
Okay.
moment ఎంత వచ్చింది already మనకు 0.4. Okay, we need to calculate the current. Area is given how much for me in the problem? Area is given for me as 2
2
centimeter cross
centimeters
section
square.
area is 2 centimeters square. That means that will be equal to 2 into 10 to the power of minus 2 whole square. That means it will become for me 10 to the power of minus 4.
Minus 4. Yes, sir. 1000
Into number of
turns, sir.
turns are given for me as 1000.
1000.
So I can calculate the value of current from this one, see how much I'm getting. So this will be your 2 ones, this one is 0.2. Antena?
Yes, sir. Yes, sir.
That means this will be equal to 2 by 10. That is nothing but I into 10 to the power of minus 4 into 10 to the power of 3.
Yes, sir.
So this will become for me how much? This will go here right now.
Yes, sir.
So
Will
that
become
will be
minus.
equal to how much? 10 to the power of 4.
Yes, sir.
Idi cancel అయిపోతుంది.
Yes, sir.
So current will become how much for me? I is equals to 2 amperes.
Yes, sir. Got it.
Got it, kada? Simple
Yes, sir.
calculations.
Yes, sir.
Clear?
Yes,
So
sir.
these two questions are very good questions, better where how to calculate the work done. So problems are being done very neatly, basically. Okay, na? Chalo. Next one,
Yes.
chalda. Serious question, beta. At 45 degrees to the magnetic meridian, the apparent dip is 30 degrees. Find the true dip. Find the true dip.
Yes.
Idea on the true dip angles, vertical angles, part affiliations. Like what the mala, it will take some lot of time for us. Phi is representing me the true dip beta. You should also know what is
Okay.
the vertical dip or plot affiliation. Diagram gurtunda.
అంత
Dip
proper గా
declinations. Okay, na?
Yes, sir.
అయితే మనం ఒక టాపిక్ చెప్పుకోవాల్సి వస్తుంది మనకు. జియోగ్రఫిక్ మెరిడియన్, మ్యాగ్నెటిక్ మెరిడియన్,
Yes, sir. అది ఉంది, sir.
డిక్లినేషన్స్ కొంచెం ఐడియా ఉంది కదా?
Yes, sir.
నేను కొంచెం ఇక్కడ చెప్పేస్తాను, చూడు ఒకసారి.
Okay, sir.
ఓకేనా? చూడు.
Yes, sir.
In the magnetism beta, if you see this diagram, this is the magnet beta. This black color
Yes,
one
sir.
is your magnet.
Yes,
And this
sir.
is the vertical line. This circle is your earth. This circle is your earth part affiliation. And this is the axis which has been passing through exactly center. So this line is called as geographical north pole, and this point is called as of your geographical south pole. Okay?
Yes, sir.
This vertical line. This is your north pole of earth, and this is the south pole of your earth. అందుకోసం geographical south and geographical north అంటున్నాం.
Okay, sir.
Okay. Now we know that at the center of the earth, it is a core of a magnet kabatti. We are assuming as if certain magnet has been present at the center, then the axis of the magnet is not exactly along the axis of the earth. It is slightly inclined. Say how much angle it has been inclined right now? You are 11.5 degrees,
7.5 degrees.
isn't it? So now
Yes,
the
sir.
axis which has been passing through the magnet is called as of here. This is called as geomagnetic north pole, and this is your geomagnetic south pole.
Okay, sir.
Okay, and this
Yes,
part
sir.
is known as of your equator. This part is known as of your magnetic equator part affiliation. Okay, now.
Yes, sir. Yes, sir.
So what is the magnetic axis and what is the geographical axis? And can you tell me right now for me? So this part, this axis is called as what? Magnetic axis. This one is called as of what? Geomagnetic
Geography.
axis.
Yes.
No, geographical part. So if I'm
Yes,
asking
sir.
you geographical meridian, it is a vertical plane. This is the vertical plane which is passing through the geographical poles. If I take a plane right now like this, which has been connecting like this plane, vertical plane, so that plane will be called as of your what? Geographical meridian. If
Yes.
I take a vertical plane on this one, that will be called as of your magnetic meridian.
Yes, sir.
And this is a magnetic equator beta. That means the circle which can form through this one. This is called as of your magnetic equator. Okay.
Yes, sir.
Now, once again, see what I'm telling you is, if I take a plane along the geographic north and geographic south, a vertical plane, like say keep a very huge cardboard vertically on this one. So
Okay.
that one and that one will form right now. Let's say, for example, a very huge notebook opened at the center. Isn't it
Yes, sir.
something
Yes, sir.
like this? This is the vertical plane, and this is your slightly open the vertical plane. So there will be an angle between them, beta, theta.
Yes, sir.
Isn't it? If this is the vertical plane of Earth, and this is the vertical plane of your magnet. So this is making an angle theta. This
Yes, sir.
మొత్తం ఒక vertical plane ఎట్లా అనుకో. This మొత్తం ఒక
Okay,
vertical
sir.
plane in the dot. This angle is called as of your vertical meridians.
Okay.
Okay.
Yes.
So these are the things you need to remember. So we need to remember 2-3 terms in the elements of magnetism beta. One is known as declination, inclination, or also known as of your dip part affiliation. That are very
Yes.
important, which you need to remember in this one. I'll just let you know one thing. Just to give me a time.
Yes. Yes, sir. This is only that book like friends.
Yeah, this is something like book open at the center. Okay.
Yes. Yes.
Now see, this is called as of your plane beta. This is called your magnetic meridian,
Okay.
and this is called as of your geographic meridian. Two vertical planes.
Yes.
An angle between them is known as of your theta.
Yes, sir.
Okay. This angle between these two meridians is called as declination. This one is called as a vertical line.
Yes,
Okay, na?
sir.
No, so this is called what? Geographic north, and this will be called as geographic
South.
north.
Yes.
South. Downward.
Yes, sir.
Oh, no. So this one is geographic north. This one is geographic south.
Yes.
So this is called as of your geographic meridian. Isn't it? Now see, this is magnetic meridian kabatti. Magnet axis దీంట్లోనే ఉంటుంది కదా. ఈ plane లోనే ఉంటుంది మనకు magnetic axis.
Yes, sir.
Isn't ఈ plane లో మనకు magnetic axis ఉంటుంది. అవునా కదా? Not in this one. Isn't
Yes,
it?
sir.
So if I take the vertical plane, so if I keep a magnetic needle somewhere here, so it is coming at a certain equilibrium, making an angle of 5 within the magnetic meridian.
Yes, sir.
Okay, na?
Yes, sir.
So the horizontal component of this one is BH, and vertical component of this one is BV.
Yes.
Once again, so the angle between the geographic meridian and magnetic meridian is known as declination. So what is a declination beta? The angle between the geographic meridian and magnetic meridian is called as of your declination part.
Yes, sir.
Isn't it? Isn't it? That is a basic thing you need to remember.
Okay.
Inclination or dip means the angle made by the Earth's magnetic field. This is your Earth's magnetic field. This is your Earth's magnetic field. This is your Earth's magnetic field. There is nothing but a pure B.
Okay. Yes, sir.
Okay. Angle made by the Earth's magnetic field with the horizontal direction of magnetic meridian is called inclination or dip.
Yes, sir.
This angle.
Yes, sir.
This magnetic meridian is making angle of your phi with respect to what beta? Horizontal component, isn't it?
Yes, sir. It is.
Isn't it? Now see, in this one, if I write the value of BH, can you tell me what will be the value of your BH beta? So if I resolve this B into components, this BH will be equal to how much beta? BH will be equal to B
Cos.
into cos
Yes,
phi,
sir.
na? What is a phi here? Phi is known as what? Angle of dip. Phi is known as what? Angle of your dip.
Okay, sir.
B is what? Earth's magnetic field. B is your Earth's magnetic field. B is your Earth's magnetic field. And what is the BV beta? Can you tell me? BV will be equal to your B into your
Yes,
sine
sir.
phi. So this is making angle of vertical property with respect to vectors. So what is BV right now? I can write here. BV is your vertical component of Earth's
Yes, sir.
magnetic field. This is your vertical component. This is your vertical component of Earth's magnetic field.
Yes, sir.
Of Earth's magnetic field. Clear? These formulas are very important in this one. But the horizontal component of your Earth's magnetic field is BH is equals to B into cos phi, and BV is equals to your B into your sin phi by
Sine phi.
definition.
Yes, sir.
Is it clear?
Yes, sir.
Now tell me at equator, at equator, phi will be equal to how much? 0 degrees.
Yes.
At equator, phi will become how
0
much? Tell me?
degrees.
0 degrees. Why? Why? Because that axis is exactly passing through the magnetic meridian. There is no horizontal
Yes, sir.
component of
Okay,
that
sir.
one. So horizontal component
Is
along the
becoming
magnetic
0.
meridian will be equal to how
0.
much for me? 0. Yeah. So why if phase value is becoming 0 means horizontal component will become how much for me beta?
Yes,
This
sir.
one is 0. Cos 0 is how much?
1, sir.
1. So that means this will become how much for
B.
me? B.
Yes, sir.
Isn't it? So if I'm taking that relation right now, that will become for me Z. That means the Earth's magnetic field is parallel to the field. That means a freely suspended magnet will always come in the horizontal to the magnetic field. That thing we need to remember here.
Okay, sir.
Okay, na? Then if I take
Yes.
BV at equators, what is the vertical component beta? Sine 0.
0. Because, yes.
0. Vertical component will become 0. Horizontal component will be equal to your B.
Yes.
So at equator, BH is equals to B. That means Earth's magnetic field is parallel to the Earth's surface. Okay. Then write here the Earth's magnetic field is parallel to Earth's surface. Okay. That means a freely suspended bar magnet will come in which direction? Better horizontal to the equator.
Yes.
Point you need to remember: a freely suspended magnet will be horizontal to equator. This point you need to remember, very important for competitive exam. So a freely suspended magnet will always come what? Horizontal to the Earth's magnetic field.
Yes, sir.
At poles, now you tell me beta. At poles, phi value will be equal to how much will be 90 degrees. That means pH will become how much? Horizontal component will become how much? B into cos 90. Cos 90
0,
is
sir.
how
0,
much?
sir.
0. So cos 90 is 0 means horizontal component is becoming for me 0. Horizontal component is becoming 0. That means there is no horizontal component at the poles. Whereas vertical component will be equal to how much for me?
Because
B.
time.
Yeah. That means I can say that at poles, a freely suspended magnet will be in the vertical edge of poles part of relation. So I can say that a freely suspended magnet will be vertical at poles. There is no horizontal component in this. Is it clear?
Yes.
Okay.
Clear.
So these 2 points are very important beta. At equator, phi value is 0 kabatti. At equator, phi value is 0 kabatti. So at the equator, we are having only the horizontal component. Vertical component will be 0.
Yes.
At poles, horizontal component is 0 and vertical component will be equal to your B part relation.
Yes.
Okay, na? Now this is something very important beta for your competitive examinations. This you need to remember the angles very importantly. I'll try to show you the
Okay.
diagram. Okay. See this. What is this one beta? This one is what? Magnetic
Magnetic
meridian.
meridian. Yes, sir.
Yeah, this one is your magnetic meridian. Okay.
Yes.
And what is this one? This one is your
Earth meridian.
geographical
Geographic.
meridian.
That's all.
Geographical or Earth's magnetic
Yes.
meridian. Meridian. Is it clear?
Yes, sir.
Isn't it? This is the magnetic needle. What is phi? Phi is your dip.
Yes,
Or
sir.
what
Between.
is other name for the dip? Dip or
Inclination.
inclination.
Yes, sir. Sorry.
Dip or inclination. Now we are getting a new term here. See, alpha. What is
Okay.
this alpha? This is very much important. I'll try to help you out in this one. You see,
Yes.
this vertical is right now. This alpha is C right now. This alpha is the angle between what beta? This horizontal component BH and this BH dash.
Yes, sir.
That means I'm writing here. See, in a vertical plane, in a vertical plane, in a vertical plane, making an angle alpha, making an angle alpha to the magnetic meridian, to the magnetic meridian, to the magnetic meridian. Vertical plane making an angle. This is right now for me what beta? This is the horizontal component of this one, and this is the magnetic meridian. Alpha is the angle between right now what beta? This is BH dash kada. So BH dash
Yes.
is nothing but BH ni resolve చేసుకుంటే ఈ BH is right now making angle alpha with the vertical component of the Earth's magnetic field. This is the vertical component particulation. ఈ BH ని రిజాల్వ్ చేసుకున్నాం అనుకో ఈ డైరెక్షన్ ఏమైపోతుంది BH dash అయిపోతుందా?
Yes, sir.
And this will become for me right now for this one, this will become for me BV dash.
Yes, sir.
Okay, na?
Yes.
Isn't it? So once again, you see, if the vertical plane is making an angle alpha to the magnetic meridian, see this alpha is the angle with the magnetic meridian. This one is the magnetic meridian. Okay, na? This one is your magnetic meridian, Dada.
Yes, sir.
Alpha is the angle made by this geographical meridian with the magnetic meridian. That means I can write here BH dash will be equal to your BH into your cos alpha. Can I write?
Yes, sir.
BH ni if I resolve in horizontal, here it will become for me BH into your cos alpha.
Yes.
And B vertical component BV dash will be still BV only, na?
Yes, sir.
Any vertical component same only there.
Yes, sir.
దీని యొక్క హారిజాంటల్ కాంపోనెంట్ ఇక్కడ వస్తుంది, వర్టికల్ కాంపోనెంట్ కిందకి వస్తుంది. సో
Yes.
దిస్ BV will be equal to BV dash.
BV
So
dash.
BV
Yes,
dash
sir.
is
Same
equals
thing.
to BV. So that
Yes.
means the angle of DP is the vertical plane making an angle alpha with magnetic meridian will be how much better? I can say here right now. So angle of dip in vertical plane, angle of dip in your vertical plane making an angle alpha, with magnetic meridian,
Yes, sir.
with magnetic meridian. So can I write here right now? The new angle will be equal to how much?
Tan.
Tan phi dash will be equal to your BV dash divided by your BH.
Okay, yes.
Angle of the dip in the vertical plane making an angle alpha with the magnetic meridian. So now the tan phi will be equal to your BV dash divided by your BH dash.
Yes.
Okay, na? So now BV dash is how much for me? BV only. BH dash is how much for me? BH into your cos alpha.
Yes.
Okay, na?
Yes, sir.
Tan phi will be equal to your, see, BV by BH will give me how much better? BV by BH from this one is BV by BH will give me how much? This two. BV by BH.
BV will get
Divide both of this.
tan phi, sir.
Tan phi
Yes,
will
sir.
get. Avuna kada? So can I write here right now tan phi? So that will become for me your tan phi divided by your cos.
Yes, sir.
Isn't it? I hope what is clear right now? What is a phi dash beta? Phi dash is nothing but what? Angle of your dip in the vertical plane. Making an angle what? alpha with the magnetic meridian.
Yes.
So the new angle of your dip is represented by tan phi dash.
Yes, sir.
Okay. So here phi dash is known as apparent dip. Is known as of your apparent dip. And phi is known as of your true dip. Phi is known as of your true dip.
True.
And what is alpha beta? Alpha is what beta? What is an alpha? Alpha is your angle made by the alpha is nothing but what? Angle made by the vertical plane to the magnetic meridian. Already in Russian and Malvas
Yes.
Russian to starting. Yeah. The in a vertical plane, in the vertical plane. Yeah. In the vertical plane, making an angle of your alpha to the magnetic plane.
Okay, sir. Sir, once can you show it in the diagram, sir?
Yeah, see this one. This is your alpha. Isn't it?
Okay,
This
sir.
is
Yes.
a true angle. This is the true angle.
Yes.
Isn't it? So true angle is so this angle right now. What I'm taking is right now for me. Previous one, this was a true angle right now. Show you see. I'll represent here by tie dash. So this angle is of your true angle.
Yes, sir.
Okay. This theta is your declination. Theta was your declination. Now this theta is being changed to alpha. Then theta is being changed to alpha. This inclination, whatever you are calling, this inclination will become for me phi dash. This phi dash will be equal to what beta? Apparent dip. This phi dash. Phi is your dip, and phi dash will be your apparent dip. Apparent dip. This one is called as of your true dip. Phi value.
Okay, sir.
Okay, na? Sure.
Yes, sir.
This is a very important relation. But relation between true dip and apparent dip is tan phi is equals to your tan phi dash is equals to tan phi divided by cos alpha.
Yes.
Okay, na?
Yes.
That is really very important. Now see, for a plane perpendicular to the magnetic meridian, like say if I take alpha is equals to 90 degrees. If
Yes,
alpha
sir.
is equals to 90 degrees, what happens? Cos 90 is how much?
0, sir.
0. That means tan phi dash will
Is
be
equal
equal
to
to
tan
your tan phi.
Yes.
That means tan will get cancelled.
Yes.
Phi dash will be equal to phi. That
Phi.
means what? Apparent dip will
Apparent
be
and
equal to your
true dip
yeah. Apparent dip
is equal
will
to
be
true.
equal to your true dip. You may ask at what angle it will be means alpha must
Perpendicular.
be equal to 90 degrees
Yes,
perpendicular.
sir. Perpendicular.
That means if the plane perpendicular to the magnetic needle becomes vertical, then we'll get that relation. Is that clear?
Yes, sir.
So when alpha is 90 degrees, phi dash is equals to 90 degrees. Phi dash is equals to your perpendicular
90.
part. Phi dash will be equal to your phi.
Yes, sir. Yes, sir.
So for a plane perpendicular to the magnetic meridian, phi dash will be equal to phi part. That is in a plane perpendicular part. So
Yes,
if
sir.
I am changing that value, now see, if at a given place, phi 1 and phi 2, are angles of dip into arbitrary vertical planes,
Yes, sir.
okay, which are perpendicular to each other, okay. Now see, we have generally got an angle between the true dip and the original dip. That means at any angle right now I can calculate the relation between them. Like say in this one, what is telling is, if at a given place phi 1 and phi 2 are the angles of the dip in the two arbitrary vertical planes which are perpendicular to each other. That means I can write here tan phi 1 will be equal to your tan phi divided by your cos alpha. In the same way, tan phi 2 will be equal to your, this one will be equal to tan phi divided by, this one will be cos, this one will be 90 minus
90.
alpha. Kada?
Yes, sir. 90.
If this angle is alpha, another angle will be equal to 90
90
minus
minus
alpha. That means this will become for me tan phi divided by
Sin.
cos 90 minus alpha will be equal
Sin.
to your sin alpha.
Yes.
Can I write like that?
Yes, sir. We can.
Okay, na?
Yes, sir.
So this is tan phi is equals to your tan phi 1 will be equal to tan phi divided by alpha, and tan phi 2 will be equal to your tan phi divided by your sin alpha.
Okay.
Clear?
Yes, sir.
Okay, so these are the important relations you need to remember. What is the phi here, beta? Phi is your true dip.
True dip. Yes, sir.
Clear?
Yes, sir.
So these are the important derivations you need to remember in these given conditions. Okay, na?
Yes, sir.
Now
Sir,
see this
so
question.
what do we mean by arbitrary
Orbital means
conditions?
anywhere, any position.
Okay.
See, when you're talking about the declination at Delhi, at Hyderabad, at Calcutta, Kolkata, what you call that, at Bangalore, if I'm
Yes, sir.
taking the Earth's magnetic field, that will be making different angles, Gada.
Okay. Yes, sir. Yes, sir.
So to any two different positions, whenever you are taking this angle, this formula I can take tan phi 1 is equal to tan phi divided by cos alpha,
Yes, sir.
provided phi 1 and phi 2 are the angles of the dip into arbitrary vertical planes which are perpendicular another. If he's telling
Yes, sir.
right now with 60 degrees another, if one alpha, one angle is alpha, another value will be 60 minus alpha,
Yes, sir.
like that. Okay, na?
Yes, sir.
Chalo, now see this question better, now we'll get an idea for this. Now see, at 45 degrees to the magnetic meridian, the apparent dip is 30 degrees. Find the true dip.
Yes, sir.
At the 45 degrees to magnetic meridian, apparent dip is 30 degrees. Find the true dip antunnadu.
Yes,
Ante,
sir.
if I am doing right now here, itself, this is the question. See here. Apparent dip formula endana? Apparent dip. Apparent dip is
Tan.
represented by tan phi dash.
Yes,
That
sir.
is equals to your BV divided by your
B.
BH dash.
Yes, sir. B.
Avuna kada?
Yes.
That is equals to how much for your B into your sin phi divided by BH will be equal to your B into your cos phi into your cos theta.
Yes.
Antena? That is
Yes.
equals to tan phi divided by cos theta direct ga.
Yes, sir.
Isn't it? Because this sin phi, this is nothing but of your cos.
Cos. Yes, sir. Sin by
Isn't it?
cos.
So
Tan.
sin by this is one is relation right now for me how much? Sin phi, this is sin phi by cos phi will become how much for me? Sin phi
Tan
by
phi.
cos phi is tan phi.
Tan.
This B and this B will get cancelled. That will be cos theta.
Yes.
So apparent temperature manaku angle is 30 degrees.
30
So tan
degrees.
30
Yes.
degrees is equals to true angle is tan phi divided by theta is nothing but what beta? Theta is the angle between. That means 45 degrees is the magnetic meridian. That means alpha.
Yes, sir.
ఇక్కడ మనం alpha రాసుకున్నాం కదా. That is your cos 45 degrees.
Yes, sir.
Sin 30 is how much? 1 by
1 by
root 3.
root 3.
That will be equal to your tan phi. Cos 45 is how much?
1 by root
1
3.
by root 2.
Yes.
So how much I'll be getting tan phi? Tan phi will be
Root
equal to
2
1.
by 3.
Hmm?
Root over 2 by 3. Right, sir.
Tan phi is equals to.
Sir, it will be 1 by root 3 into root 2.
Root 3 into?
Root 2. 1 by root 3 into root 2.
ఎంత అవుతుంది? 1 by root 6.
Yes, sir. 1 by root 6.
అంతేనా?
Yes, sir.
So
Because
phi
ఈ
is
root 2
equals
పైకి
to how
వెళ్తే
much?
అప్పుడు
1 by root 6.
yes, sir.
So this will be the true angle.
Yes.
Got it?
Yes, sir. Got it.
This is very, very important relation you need to remember.
Okay.
Clear?
Yes, sir.
This is something again very important. Magnetic needle is free to rotate in a fixed vertical plane, staying in the direction, making an angle of 60 degrees with the horizontal. If the dip at that place is 45 degrees, find the angle of the fixed vertical plane with the meridian. So try to understand the question first.
Yes, sir.
Magnetic needle is free to rotate in a fixed vertical plane, stays in a direction, making an angle of 60 degrees with the horizontal. If the dip at that place is 45 degrees, find the angle of the fixed vertical plane. Angle of the fixed vertical plane means alpha is
Yes,
asked.
sir.
అన్నా కదా చూడండి ఇక్కడ చూపిస్తాను. This is the relation right now. This phi dash. Tan phi dash is equal to tan phi divided by cos alpha. What is alpha here? I told you. Alpha is the angle between the magnetic meridian and as well as of your this one.
Yes, sir.
Vertical plane angle is nothing but of your alpha. Now see this question carefully. Magnetic needle is free to rotate in a fixed vertical plane, stays in the direction, making an angle of your 60 degrees, making an angle of 60 degrees with the horizontal. That means what? That means what? Apparent angle is given how much for me? 60 degrees. If the dip
Yes,
at
sir.
that place is 45 degrees, dip means phi value. If phi value is 45 degrees, then find the angle of the fixed vertical plane with the meridian. That means alpha is asking.
Okay.
Alpha is equals to your how much? And dip value is given as 45 degrees. And apparent angle is given as 60 degrees. So what is the relation between them, beta? Tan phi dash apparent dip will be equal to your tan true dip divided by your cos of your alpha. Antena?
Okay. Yes, sir.
Phi dash is what? Apparent dip. Phi is what? True dip. Theta is nothing. Here alpha is nothing but what beta? It is the angle made by the vertical plane with the meridian.
Yes, sir.
Alpha is nothing but right now for me what? Angle made by the vertical plane. By vertical plane with meridian.
Yes, sir.
Which meridian? Magnetic meridian. So I need to get the value of cos alpha. So cos alpha is equals to tan phi divided by your tan phi dash. Okay.
Yes, sir.
So that is equals to tan phi dash value is 45 degrees. Tan phi dash value is 60 degrees. Tan 45 is how much?
Uh, 1, sir.
1. Tan 60,
Root 3, sir.
root 3. So it is 1 by root 3.
Yes.
So alpha will become how much for me? Cos inverse of your 1 by your root.
Yes.
Clear?
Yes.
Chalo, next one. A dip circle shows an apparent dip of 60 degrees at a place where the true dip is 45 degrees. If the circle is rotated through 90 degrees, what is the apparent dip? It will be showing. You can try to do this one better. Two dips. Phi 1 and phi 2 is given for him.
Yes, sir.
Okay. A dip circle shows an apparent dip. Apparent dip means what? Phi.
Yes.
Phi value is given how much for me? For first apparent dip is nothing but phi 1. At a place it is given 60 degrees.
60 degrees. Yes.
True dip is 45 degrees.
Yes.
The circle is rotated through 90 degrees.
Yes.
Okay.
Yes.
So it is being rotated by 90 degrees. What will be the apparent dip? It will show. That means phi 2 value will be equal to how much? I told you right now the formula of phi 1 and phi 2.
Yes, sir.
Go to phi 1 and 2. Two different positions arbitrary positions.
Yes, sir.
So tan phi 1 is equals to tan phi divided by tan phi 2. In order to get the tan phi 2 value, I should know the value of alpha.
Yes, sir.
Yes.
Sir.
Can I do it like that?
Yes, sir.
So try చేద్దాం నాకు సార్.
Okay.
So number B try చేసుకుందాం ఇక్కడ so that you can practice it. Let's see. Phi 1 and phi 2 are what beta? Apparent dips kabatti. I know the value. I know the formula for this one. What is the formula we got? Tan phi 1 will be equal to tan phi divided by alpha. Tan
yes.
phi 1 will be equal to your tan phi divided by what beta?
Cos alpha.
Cos alpha. No sin. A dip circle shows an apparent dip at 60 degrees. That means phi 1 is equals to 60 degrees. And true dip is equals to how much he has given for me? True dip is 45 degrees. True dip is 45 degrees. So can I get the cos alpha value? So this is the tan 60 is equals to tan 45 degrees divided by cos alpha. Tan 60 is how much?
Root 3, sir.
Tan 60.
Yes, sir. Root 3, sir.
Tan 45.
1 by root 3, sir.
So tan 45.
Sorry, 1. Sorry. Tan 30 is 1.
Cos alpha will become how much for me? 1 by root.
1 by root 3. Okay, sir.
Okay, na?
Means
So
alpha value is 30,
alpha
right,
value
sir?
is cos inverse of 1 by
30. Yes. Sorry.
So next one is tan phi 2 will be equal to your how much? That means for what value it will be 1 by root 3 beta?
Sir, cos inverse of 1 by root 3.
That means for what angle? 30 degrees or 60 degrees or what degrees? Will I be able to get like that?
No, sir.
Yeah, fine. Then I can write this one as tan phi is equals to, what is the next formula beta? Tan phi is equals to your tan phi 2 is equals to tan phi divided by sin alpha.
Yes.
So it is your tan phi divided by your sin of your alpha.
Yes.
Okay, na? So when I know the value of cos alpha, can I get the value of sin alpha?
Yes, sir.
So tan phi 2 will be equal to your tan phi is how much for me? 45 degrees. Cos means what angle beta? If I take the triangle right now like this one, this is making an angle alpha.
Yes.
Which side by which side is cos beta?
Sir, adjacent by hypotenuse, sir. So bottom root 3.
That means this is how much?
1, sir.
This one is how much? This is 1. This one is?
No, that is root.
That is root 3.
Yes,
this
sir.
one will be root 3. This will be 1. So this will be? Road perpendicular kada?
Yes, sir.
The 2 avala. See, this is 1 and this is 2.
Yes,
so
sir.
This
yes,
is
sir.
your 2. 2 కాదు. This will be equal to your how much for me? 2 square అయిపోతుంది.
అదే సార్.
This one will become how much for me? This side will become how much? Under root of 3 square minus 1.
Yes
అంతే
sir.
కదా, Pythagoras theorem కదా అన్న.
Yes sir.
If this is your x, this is your y, this will be under root of your x square plus y square. That means this is a resultant. That means r will be equal to your under root of your x square plus y square కదా.
Yes
అవునా
sir.
కదా. R value is given how much for me? R square రాసుకున్నా. This will become for me x square plus y square. That means R square value is given how much for me? Better root 3 whole square.
Yes sir.
X square is 1 square. This will be your y square. That means this is 3. That is equals to 1. This is your plus y square. That means y square will become how much for me? R square value is root 3. Better. This
Yes
is
sir.
root 3. So y square value will become how much for me?
Y square would be
Root 3
root 3 minus 1 sir.
root 3 minus 1. అంతే కదా.
Yes sir.
So this will be equal to how much for me? Sin alpha will become how much right now then?
Yes sir.
Sin theta is which side by which side? This one is right now for me root 3 minus 1. So sin theta means which side by which side?
Sin theta is opposite by hypotenuse sir. Means we'll get
Mm.
root 3 by root 3 minus 1 by
Root 3 minus 1
divided by root 3. Root
divided by
3.
అంతే కదా.
Yes sir.
This side by this side.
Yes sir.
Tan 45 is how much?
1 sir.
1. So this will be root 3 means this will be 1 by
Yes,
root
sir.
3. Yeah. So 1 minus 1 by root 3 is how much?
Again we'll get the same value right sir.
LCM will 1 minus 1 by root 3 is how much?
Root 3 minus 1.
LCM తీసుకో.
Root 3 minus 1 by root 3.
Mm.
So we can actually send the root 3 up. So root 3 by root 3 minus 1.
Mm. That will be equal to how much? Root 2 kada.
Okay, yes sir.
So can I write total under root of 2 by 3?
Yes sir.
So phi 2 will become how much for me? Phi 2 will become for me tan inverse of your root of
Root
your
2. Yes sir. Root 2 by root 3.
Got it?
Yes sir. Got it sir.
So just take the care of your calculation. Everything will be getting out for you.
Okay sir.
Okay.
Yes sir.
I can make one shortcut formula beta. I hope you already done it. I'll try to do the derivation of this one later.
Okay sir.
You can do it by alternate method also.
Yes sir.
Alternate method. That is relation between them. That is cot square phi will be equal to your cot square phi 1 plus of your cot square phi 2. Your sir might have been
Yes,
derived
sir,
this
yes.
relation. You just see it in your notes.
Yes.
Phi value is 45 degrees. So this value will be equal to cot square 45. That is equals to your cot square. This angle is 60 degrees. Plus we need to get the value of cot square
Yes,
phi 2. Cot 45 means this will be equal to 1. This will be equal to your 1 by root 3 kabatti 1 by 3. So cos
Yes,
square
sir,
kada.
1
So
by
this will be your cos square phi 2. So it is 1 is equals to 1 by 3 plus this is your cot square phi. So what will be the answer for this one? You see. So phi 2 will become how much for me? 1 by 3 minus 1 ఇక్కడ వెళ్ళిపోతుందా? That will become for me 2 by 3.
Yes sir. 2 by 3.
అంటే
Okay,
this
under
will
root
become for me how much for me?
Yes sir. Under root will come on this.
అంతేనా?
Yes sir. Direct గా వచ్చేస్తుంది sir.
You can calculate the value from this one.
Yes.
Okay na?
Yes.
Cot square phi 2 value is equals to how much? Of phi 2 value is equals to 1 by 6. You can simplify that one. Okay
Yes.
na?
Yes.
This one is again a direct question. I'll try to do it later. What got time period form problems, beta?
Yes sir.
Time period చెప్పారా కాలేజ్ లో?
Yes sir.